Hello everyone. I think all of you are getting ready for forthcoming JEE examinations. JEE main, advanced, then JEE advanced, WBJEE exam there, BITS Pilan is there. Some topic which you have already finished in class 11, from class 11 matter. I am not going to discuss about those topics at this moment that I have done in another session. Here I like to discuss the topic you have recently finished, that is one of them is application of derivative. I am not saying that it is the most important topic, but it is very important topic. It plays very significant role to score good marks in JEE paper. Papers can be answered easily with the help of concepts of application of derivative. That application of derivative can be extended to explain some concept in coordinate geometry, some algebra chapter, polynomials. It plays very important role. So I have selected this topic to discuss with you, which is known as Rolle's theorem. Today I will be discussing what is Rolle's theorem, and then area of application I will be discussing one by one. May not be in this session, in forthcoming sessions I will be discussing all those. First, let us know what is Rolle's theorem. Rolle's theorem states about the function which is continuous in a given interval, which is differentiable in open interval, and which has functional values same at 2 points. What do you mean all these? Before we enter this mathematical concept, let us take the graph of a function, where we will find that it is quite reasonable to state that if a function has a horizontal chord, this is the chord, AB is the horizontal chord, this is the chord AB for this graph. Now, it is quite reasonable to say that this function which has a horizontal chord has tangent between those 2 points. At least one tangent between those 2 points which are parallel to x-axis. So this is the graph of function. What do you see there? That graph we have plotted without raising the pen or pencil. What is the meaning of this statement? Without raising pen or pencil means the graph must be continuous between these 2 points. When you draw perpendicular, suppose this foot of perpendicular has coordinate a, 0, and this point has coordinate b, 0. So this horizontal tangent, what do you mean? The functional value at these 2 points must be same. Another most important condition is there, the graph cannot have any kink in between these 2 points. So non-differentiability condition is removed. The function must be differentiable, it must be continuous. If it is continuous, it may or may not be differentiable. But differentiability implies continuity. But here we will be discussing continuity and differentiability over 2 different intervals. One is the closed interval, one is the open interval. So if we take the function is y equal to fx, and this is the graph of function, at these 2 points at a and b functional values are same, then there will be at least one point where the tangent will be parallel to chord or parallel to x-axis, because this was horizontal chord. These tangents, I have shown you 3 points between a and b where tangent parallel to x-axis. Mathematically we can say that let y equal to fx be number 1 continuous in AB, number 2 differentiable in AB, number 3 FA equal to FB. Horizontal tangent means that horizontal chord means this third point, no? Continuity means you have drawn the graph without raising pen or pencil. Differentiable means there is no graph, there is no kink in the graph. Then if all these 3 conditions are obeyed, then there exists there exists at least, this is the symbol for there exists, at least one point C between A and B, you can say that is C belongs to this open interval AB such that f dash C equal to 0. From geometrical meaning of derivative, you know, if the function y equal to fx is there, then its derivative dy by dx or f dash x has a geometrical significance. This f dash x is nothing but slope of tangent. So slope of tangent will be 0, means tangent at that point will be parallel to x-axis. So 3 points are found here, L, M and N. Tangents are parallel to x-axis at these 3 points. So this is Rolle's theorem. Just by plotting the graph without raising pen or pencil, just by observing there is no kink in between two given points, two known points A and B, and just by seeing that there is a horizontal chord, that is functional values are equal at those 2 points, we can say that it is quite reasonable to say that there exists at least one point in between A and B where tangent parallel to x-axis. There may be many points, there may be just one point, there may not be any point where tangent parallel to x-axis. But here it is possible when all these 3 conditions are obeyed. And before we go for application of this, we need not prove it. You just realize it and apply it. Why Rolle's theorem? What is the application of Rolle's theorem? That we'll know. Proving that hardcore algebraic proof is not required here. You just remember the graph of the function must be continuous, it must be differentiable, and functional values must be equal. Now, before you are going to apply this concept, let us know what the theorem actually states. It states that the tangent at a point in between A and B will be parallel to x-axis. Means here we are going to determine that point, at which point it is parallel to x-axis. If we find a point, then Rolle's theorem is verified. Then as it states at least one point C between A and B, where C belonging to this open interval such that derivative equal to 0, this will be obeyed. So we will find the point in application sums. Before doing that, as we are discussing some graphical concept, let us discuss whether Rolle's theorem is applicable for these functions or not. The graph of function we have drawn this manner. These are 2 points on the graph A and B. Obviously, this is a horizontal line. You have to decide whether you can apply Rolle's theorem here or not. Is the Rolle's theorem applicable here? And next curve is like this. Can we apply Rolle's theorem over there? Decide. And then next one is and another curve I am drawing. This is the point say 3, 0, and we have drawn the graph of absolute value function. Can you use Rolle's theorem in case 1 in figure 1? Yes, because this is the graph of straight line parallel to x-axis. Obviously it is continuous, obviously it is differentiable, and I told you there must be a horizontal chord. This curve is itself a chord only, like this. So here Rolle's theorem is applicable. We can apply Rolle's theorem. So there are many points between these 2 points where tangent will be parallel to x-axis. You state that manner. Is it possible to apply here? Yes. We can easily draw horizontal chord over there. How do you get horizontal chord? You join any 2 points here. You will get a horizontal chord. This is horizontal chord AB. So there exists a horizontal chord, there is a point P where tangent will be parallel to x-axis. Now for this curve we can draw many horizontal curves. Between these two we can draw horizontal chord. Between these 2 points also we can get a horizontal chord. So there exists at least one point where tangent will be parallel to x-axis. So 2 points are there if we take the points A and B here. Is it possible here? Here you will get everything. What you will get if you take any 2 points on the curve, horizontal curve drawing is possible. We can do it easily, these 2 points. But you must take care, graph is not enough. Whether the graph has a kink or not, that you need to check. This is obviously going to be the graph of y equal to mod x minus 3. It is not differentiable at x equal to 3. Why? As per our discussion in previous videos, dy by dx at this point, I mean that r f dash 3, it has value equal to, I mean at this point, this angle 45 degree, this is tan 45 1. And what is a f dash 3? This is going to be minus 1. So for this function, here Rolle's theorem was applicable in number 2. Number 3 Rolle's theorem is applicable, but here Rolle's theorem is not applicable. Why not applicable? Because the graph, I mean the function, the graph has a kink, or the function is not differentiable at x equal to 3. So Rolle's theorem is not applicable over there. Now let us see in some problem how to decide whether Rolle's theorem is valid or not. Rolle's theorem is applicable or not. Let us take the simplest example, that is fx equal to, say I am taking x square minus 3x plus 2 in 1 comma 2. Can we use in 1 comma 2 Rolle's theorem? We take it at closed interval at this moment. Derivative we will check in the open interval. Is Rolle's theorem applicable for this function? Graphically if you go, then you will say that I have the answer. Graph if you draw, graphically if you go to plot the graph, it is the graph of parabola. Y minus 2 equal to x square 2x 3 by 2 9 by 4 plus 9 by 4 here. So y plus or y minus minus 1 by 4 x minus 3 by 2 whole square. So if we plot the graph, the vertex is going to be 3 by 2 comma minus 1 by 4 and the parabola opens upward. It's almost like this. Then you will say that I can get horizontal chord between 2 points. So I will get a point, at least one point where tangent is parallel. For parabola it's a known curve. At this point tangent if you draw, it must be parallel to the x-axis. That's true. But analytically, if they have asked you to verify whether Rolle's theorem applicable for this function or not, in the interval 1, 2, how do you check? Let us verify it. This is graphically, algebraically we are going to do. So fx, you can see that it's a polynomial function. So being a polynomial function, fx is number 1 continuous in 1 comma 2. 1 is a point somewhere like this. 2 is a point somewhere like this. It is continuous. So continuous in the closed interval. This interval must be closed. Differentiable in the open interval. And number 3, f1, if we check, it is going to be 1 minus 3 plus 2, 0. And f2 is what? 4 minus 6 plus 2, 0. So fa equal to fb. So Rolle's theorem can be applicable if we get a C in between 1 and 2. So let us see whether we can get C over there or not for this function fx equal to x square minus 3x plus 2. So after proving this, you write there exists a point C in the open interval 1, 2 such that f dash c equal to 0. What is f dash c? Fx is given as x square minus 3x plus 2. So f dash x is 2x minus 3. So this implies that c equal to 3 by 2. Okay. Now let us verify Rolle's theorem for another problem. Let us take fx equal to cube root of 8x minus x square in 0, 8. We are not going to plot the graph of this function. Graph plotting here may take more time than the algebraic method. So we will be solving it with the help of algebraic method. Algebraic method means what? You have to check whether it is continuous or not. Is there any point of discontinuity of the function? Let us verify it. Here, if you write fx, this is nothing but cube root of x into 8 minus x. So when x greater than equal to 0, less than equal to 8, this implies x into x minus 8. What about x minus 8? X minus 8 greater than equal to minus 8. Okay, don't say minus 8. We need to check whether this thing positive or not in this interval. X into 8 minus x greater than 0. This implies x into, I am changing the inequality, multiplying this by minus 1. This has to be less than equal to 0. Why? Because 8 minus x changed to x minus 8. We need to multiply it by minus 1. So x into x minus 8 less than or equal to 0. This implies, if you go by number line concept, in 0, 8 interval, this function obeys this condition. That is x greater than equal to 0, less than equal to 8. Beyond 8, the function x into x minus 8 is positive, and before 0 also both are negative, means product positive. Here only it is negative. So what about this function? This function fx is, you write this manner. Obviously fx is number 1 continuous in 0, 8. Number 2 differentiable in 0, 8. How do you check differentiable in 0, 8? Here there is no problem if you find derivative of the function. Fx is 8x minus x square to the power 1/3. So f dash x is nothing but 8 minus 2x. So minus of 2 into x minus 4 by 3, that is 1 by cube root of 8 minus x. It is differentiable in 0, 8, and because that derivative when you are going to find, it is going to be 8x minus x square. If we choose the open interval, then there is no chance of getting something by 0. That's why you can say that it is differentiable in 0, 8. All of you understand? Because this term vanishes when x equal to 0 and x equal to 8. So it is differentiable in 0, 8. And another most important thing is that f0, the value, if you put 0 here, it is going to be 0. f8, 64 minus 64, then also it is 0. So it is obeying all the conditions of Rolle's theorem. So there exists by Rolle's theorem, f dash c must be 0. Where does C go? C must lie in this open interval 0, 8. So this implies that you check the derivative here, minus 2 by 3, C minus 4, 1 by equal to 0. This thing cannot be equal to 0. So numerator equal to 0. C equal to 4. Since 4 belongs to 0, 8, so Rolle's theorem is applicable in 0, 8. Okay, you can use Rolle's theorem in 0, 8 because it was continuous, it was differentiable. There is a horizontal chord because f0 equal to f8, and there is a point C where derivative must vanish. That point C is 4 and it lies between 0 and 8. So Rolle's theorem is applicable for this function in the interval 0, 8. Let us see another problem here, and it's a very good sum. We'll decide its continuity, differentiability, everything by using the concept of log function, that is fx equal to ln. Ln means basic exponential x square plus ab, that divided by x into a plus b, and they have asked you to check the difference, the applicability of Rolle's theorem in the interval a comma b. Can you use Rolle's theorem over there in a comma b? It's a bit difficult sum for you. It is not that it is not algebraic function, it is log function. Is there any point of non-differentiability? I clarify that part first. Here you take a and b both positive quantities first, because if a and b are negative, that it can make this one negative if x is negative, if x is positive. So I am telling you to take this a and b both are greater than 0, less than infinity. Okay, so you take positive values first, and we'll remember some basic properties of log to solve this sum. So let us answer it. Fx equal to, obviously you are not going to plot the graph of this function. Plotting will take long time for this function. So you write this as ln x square plus ab minus ln x minus ln a plus b. So let us find derivative also for this function. So f dash x is 2x by, you all understand, x square plus ab minus 1 by x minus 0. So you take x square plus ab so this thing is x square minus ab by x into x square plus ab. Now this function, in the construction of this function, you can see that there is no point where the function is discontinuous, because we took a and b positive. So ln x defined, ln x square plus ab also defined. So let us proceed accordingly. Fx is continuous in ab. Number 2, differentiable in ab. Number 3, f of a equal to ln ln 1 0 this is also 0. Okay, since they are all equal to 0, a and b are 0, therefore fa equal to 0 equal to fb. So all the conditions of Rolle's theorem satisfied for this function, but still we cannot say it is applicable over there. If it is applicable, we need to get a point C in between a and b, but derivative must be equal to 0. So there exists this f dash x is here. So therefore there exists C in the interval AB such that f dash C equal to 0. So you put C over there, C square minus AB. So C equal to under root AB. Now root AB is the geometrical meaning between A and B. Since C is greater than A less than B, so Rolle's theorem is applicable. Rolle's theorem we can apply for this one also because root AB is the geometric mean and it is applicable over there.